Hello and welcome to the if then else tutorial. In this video, we're going to be going over the different ways that the programming concept if then else manifests in PlayMaker. That is to say, how you could program things by saying if X happens, then Y happens, else or otherwise Z happens. This concept manifests in many different ways, and we're going to go over just a few here. And we're going to start off with some action. If you look over here in my hierarchy, I have some examples set up. You can see that we have some compare actions, switch actions, and test actions. Let's go over the compare actions first. So a system that can help illustrate if then else is a health system. I have this health compare here, and in it I just have a couple of actions. You might call this FSM something like health. This could be your player's health or an enemy health, or even the health of an object if you're doing damage to it. Now this is a very common setup, is you're going to use a float variable to be the health, and then you could use a float compare that says when it's below a certain number, that means that the player or the enemy or whatever the item is should either die or break. For example, we have this random float here. Now the random float is going to give me a value between 1 and 10. We'll store it here in a new variable called health, and then we have this float compare that will check that health variable against 0. And this is where if then else comes in. These options for equal, less than, and greater than. If my health is equal to 0, then we send off to a dead state. So I'm going to add this transition and they'll go to a state that we can just call dead. We'll call this one alive. And then next we have this less than. So if my health is less than 0, then we also want to go to dead. And next we have this greater than, and this is what our else would be. So if our health is equal or less than 0, then go to dead, else or otherwise go to still alive. And we can go here, still alive. So if we run this, okay, so our random float gave us 8.7, and since that's higher than 0, we're still alive and we're here. Now, it's gonna take a minute if I keep using this random float to try to get a 0 here, but if I set my minimum to say -50 and hit play, the random float gave us a value of -41.9 and it sent off to dead. So this random float gave us a value of -41.9, then this float compare said, well, if our health was equal or less than, in this case less than, then we send off to dead. So that's how it might show up in a health system with a float compare. Another example is comparing game objects. So with the game object compare action, you have a equal event and a not equal event. What this action does is it takes a game object, it compares it to another game object. It does something if it's equal, and it does something different if it's not equal. So for this equal event, we'll say new event, the same object. We'll add that. And the not equal event is not the same object. And we'll add that. The same object will go here and not the same object here. So this state will be called they are the same. And this one is they are not the same. In this first one, we have select random game objects. What I could do is just drag in my cube here, drag in my sphere, drag in another sphere. Yellow cube, yellow sphere, and red sphere. Red sphere, yellow cube. And now in the select random game object, I'll say that you could select between the red sphere, the yellow sphere, and the yellow cube, and then store that random object into random object. Now I want to compare, I'll specify, let's say for the first example, the red sphere. We'll compare it to the random object. If they are the same, this equal event, they are the same object, then go here. Else or otherwise, go here. Let's hit play. Okay, and we got sent off to they are not the same because it chose the yellow cube. But if I come over here to the select random game object and I say, well, let's change the odds of getting a red sphere to something like 5, and then we hit play, we'll have a better chance of matching. And sure enough, the random game object it chose was a red sphere, and of course it sent off to they are the same. Next up, we have this game object compare tag action, and this does something very similar, it just checks the tag on the game object. So for example, we can go to this red sphere and we'll say that the tag is player, and these other ones are just untagged. So the only one that's tagged as something is this red sphere, and it's tagged as player. Come over here to the tag compare, and we'll say you're gonna look at the red sphere, the yellow sphere, and the yellow cube. Pick a random one from there, store it in a new variable, also called random object. And then we're gonna get the tag from that random object, and we're gonna check if it's tagged as player. If that random game object's tag is player, then send off is the player. And it'll go to the state called is the player. But if that game object's tag is not the player, then send is not the player. And it'll send off to this next state is not the player. Okay, so let's give that a go. Right, so it chose the yellow sphere, and as we know with the yellow sphere selected, it's not tagged as player. So our tag compare said this is not the player. Now if I stop this, and I'm just gonna crank up the chances of getting our red sphere to 50, and I'm gonna hit play. So now we'll very likely get the red sphere. Great. And we got the red sphere, and of course it recognized it and said it is the player. So you can see how the game object compare tag and the game object compare, they say if this game object is tagged player, then send off to is the player. Else, or otherwise, send off this is not the player event. Next up, I have this name compare example, which makes use of the string compare action. It's the same thing. This time, literally, it's just that you're checking strings. So you could have 3 strings here. They could all be names, and it could be something like Skippy, Dippy, and Quippy. And then store that into a new variable called random name. And then you could do the same thing here with the string compare, right? You would check that random name and then compare it to, say, Quippy, because of course. And then the equal event, you can have it say, if the random name is Quippy, then send is Quippy. Else, or otherwise, send is not Quippy. So you could go here and here. Hey Quippy. And you're not Quippy. Okay, and then you hit play. And we got Dippy, which is not Quippy. So it sent off to you're not Quippy. But I'm gonna crank up the Quippy chance to 1001 and then hit play. And of course, how could we not get a Quippy? We got a Quippy. String compare said absolutely. So now we're at hey Quippy. Okay, so those are compare actions. We also have switch actions. So I have a couple here. We have an int switch and a state switch. There are other switch actions. You could just type in switch to your action browser, and there's plenty of other switches in the ecosystem as well. But for this tutorial, we're just gonna go over int switch and state switch. So this int switch will have a random int between 0 and 3, store the result, new variable to random int. And we'll include the max value, which is to say it can also have 3 in there. And then we're gonna compare that random int to however many other ints we want. So this is kind of like the compare actions, except now you could say, well, I want it to have 8 things to compare to. So you can say compare it to 5, compare it to 2, compare it to 59, compare it to 106, compare it to 32, compare it to 111, 1115, compare it to 3, and compare it to 0. Okay, and you can have events for all of these. So a switch action is kind of like saying, well, if this, then that, else, 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 else. Otherwise, 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 otherwise. Or you could even just look at it as if this, then that, if this, then that, if this, then that, as many times as you want. So for this example, instead of putting this outrageous amount, I'm just gonna put 3 and we'll say it'll compare between, or actually I'll put 4. So we can get 0, 1, 2, and 3. So we'll have 0, 1, 2, and 3. Right, send event will be is 0, new event is 1, new event is 2, and is 3. Okay, and they can all go to their own states. 0, 1, 2, and 3. If we hit play, okay, sent off to 2, and you can see that our random result was 2. Next up, we have this state switch. Now, the interesting thing about a state switch action is that it actually syncs up and gets the state names of other FSMs. In this game object, I have 2 FSMs. I have the actual switch action one, that's this, and we have a FSM for different state names. So if I hop in here, we could have a few states. We'll have this first one. It'll just be called state 1, state 2, state 3. And we'll have this wait action. We'll say wait 3 seconds, and it'll just send off next, and it'll go here. Okay, and I'll copy this wait action and I'll put it in here as well. And this last one, we'll have this, except it'll send back. Okay, so we have state 1, state 2, state 3, and it's just gonna cycle through these. Now in the switch action FSM, we'll say that we're gonna be getting from our state switch the different state names FSM, and we'll have 3 state switches. And we'll compare the state 1, state 2, and state 3. This one we could send is 1, this one is 2, and this one is 3. So this one will go to 1, so we'll just send back to itself. This one will go to 2, and this one will go to 3. And I'll just put this in both of these as well. So essentially what we're creating is something that will sync both of these FSMs. So this one sends back to 1, 2 sends to itself, and 3 sends down here. 3 can send to itself, send 2 to up here, and 1 over here. Now this is getting like quite the plate of spaghetti here, and is not exactly the setup. You know, more likely you'd end up using global transitions if you're sending this many events around, and I'm gonna select every frame for all of these. So it's constantly checking. And before we start getting some infinite loop errors, I'm just gonna make it so state 1 actually cannot send to itself. It does nothing, and make sure state 2 can't send to itself, and state 3 will also do nothing if it's on itself. Okay, so now when we press play, it's on state 1. If I pause this really quick and hop over to our different namestates, you'll see that it's on state 1. When we should see that because this wait action, it'll switch states every 3 seconds, and we should see the same thing happening over here, even though this doesn't have a bunch of wait actions in it. So I'm gonna keep it playing. State 2, 1, 2, 3. State 3, 1, 2, 3. State 1, 1, 2, 3. This is how if then else manifests itself in the FSM state switch action. If the state is in, and then whatever the name of the state is, then send to, and then whichever state you want to send it to. Else, do nothing, right? So if it's in state 2, then do this. If it's in state 3, then do this. Or else, if it's in state 1, then do nothing. So those are switch actions. Now, similar to compare and switch actions, we have test actions. So you're probably familiar with the Bool test. We also have a float sign test and a state test. So a Bool test, it just tests whether or not a bool is true or false. So if we store this random bool variable into random bool, and then we test that random bool variable, if this bool variable is true, then send off to true. Else, otherwise, send off to false. Okay, so this one's true, and this one is false. So if we run this, we got false. That's our bool test. It said if our random bool was false, then we send off to false, and that's where we are. Now we also have this float sign test. So we'll say that the minimum is -5 and the maximum is 5, and we'll store that result in a new variable called random float. Then we'll test that random float and see, well, Is it a negative number or is it a positive number? So if our float value is positive, then send off to is positive. Else, otherwise, send off to is negative. Okay, so we have is positive over here and negative down here. Now this is going to run just how you expect. If you've been following along, it should be pretty clear how these things run. But what I want to show you is that this could be very useful in real world examples as well, because what you could use this for is in 2D games, for example, if something is facing left or right. On a grid, going left from the center of your x-axis, that's into the negative numbers. So negative numbers are associated with things to the left. And then going right on your x-axis, that's all positive numbers. So positive numbers are associated with going right. So the way you could use this in your game is maybe instead of saying is positive or is negative, instead of is negative, it's is to the left. And then your is positive could be is to the right. And up here is to the right and to the left. So when you hit play, you're looking at the float sign, which is whether or not it's a negative value, right? But now you're interpreting it in a less abstract way. Now you're saying something is to your right or to your left. So if this random float value is positive, that means that whatever your object, enemy, or the player is to the right. Else or otherwise, it is to the left. Okay, now we have this state test. And the state test, I don't even have to set up. You know what it is, because it's the same thing as a state switch. Except the difference here is that it bakes in the if then else into a true or false event. So instead of having to set up all the other conditions, if a thing had a bunch of states, but you're only really checking if something is or isn't on a specific state, you don't want to have to go in and say like, all right, well, we're gonna have to make 50 switches and fill in all the values for whether or not it is or isn't that one that I'm looking for, like this is the state I want, and then, you know, you'd be wasting your time saying not the state I want number 1, and then not the state I want number 2, not the state, you know, until you've done all this tedious work just to fill out all the things that you don't want it to do, right? If you wanted to do something specific when the value was false, you'd have to fill out all this stuff and you'd be wasting your time. So that's not when you use a state switch. And instead, you could use an FSM state test. And there's a sort of catch-all event where it's like, well, if it's not the state I want, then this false event covers all of them. That's the power of if then else for test actions. So if this FSM is currently in this state name, which is true, then do this. Else, if it's literally in any other state, then do this. Now, the last thing I wanted to go over was how if then else manifests itself in the action update order. So far, we've seen how if then else manifests itself within one action, but if then else is a concept that can come about in another way, which is which of these actions sends off their event first. So for example, I'm going to turn off all these other cubes right here. So for example, we have this red cube and this yellow sphere, and we have a wait action and a move towards action. So I'm going to say move the cube towards the sphere, and we'll move the speed down to something like 1, a nice slow pace. Finish distance we'll set to 0.1, so it's almost right on top of it. And this finished event will be called has reached target. Okay, so then this will go over here, reached target. And then we have this wait action, and we'll say that this waits 3 seconds. And this one will have an event called time's up. This one we'll send down here to time's up. So these actions are competing with each other. And since they're competing with each other, this is essentially if-then-else logic. So if 3 seconds passes, then send over to the time's up state. Else, or otherwise, if the cube reaches the sphere before that time is up, then send over to reach target. And you could say it the other way too, if this cube reaches the sphere, then go to reach target. Else, or otherwise, if this 3 seconds is up, then go to time's up. So we can run this. Okay, and it looks like that 3 seconds is gonna win. Okay, because our cube was moving too slow. So that if then else logic was a way of getting us to time's up first. Whereas if we set the max speed to 10, then hit play, we reach the target first. And that's how the concept of if then else finds its way into the action update order. If you want to learn more about the action update order, go check out the video that focuses entirely on that. But for now, this should give you a clearer understanding of how to use if-then-else logic in PlayMaker.
Be sure to check out our other videos to learn all the various features of PlayMaker. Links to more learning resources are in the description.